Hello, today we're going to look at factorising and coming up with a system for factorising. So I'm going to take you through these three examples and then we'll hopefully come up with a foolproof system for factorising. So first example, 3x squared subtract 75. First thing we're going to look for, and with any factorising we'll look for a common factor. So no algebra in this term, no x's here, so no algebraic common factors. Is there a common factor for the 3 and the 75? Yes, 3 goes into both. So 3 multiplied by what gives us 3x squared? That's x squared. And 3 multiplied by what gives us negative 75. So that's negative 25. Once we've looked for the common factor, we then look for the difference of two squares. So is this expression a difference of two squares? It is. Because x multiplied by x gives us x squared, and 5 squared, or 5 multiplied by 5, gives us the 25. So once we've found the expression as a difference of two squares, set up the brackets. It's x squared. If the x goes there, x goes there. It's 5 squared. 5 goes there. 5 goes there. And a plus and a minus in between, or a plus and a subtract in between. And if ever you're unconvinced that your factorising is correct, you can always expand it back out and check that it equals the original expression. Next example. First thing, look for a common factor. Is there a common factor? No. Is it a difference of two squares? No. Easy way to tell. There's 3 terms. Difference of two squares only has 2 terms. Next thing, is it a trinomial? Yes, 3 terms. Is it a 1x squared trinomial? Yes, there's only 1x squared. So we use our pattern. So we're looking for 2 numbers that multiply to give us 12 and also add to give us 7. So 2 numbers that multiply to give us 12. 6 and 2, what do they add to give us? 8. So they don't add to give us the plus 7. Another 2 numbers that multiply to give us 12. 4 and 3. What do they add to give us? They add to give us 7. Plus 7. Ideal. So we've found our numbers. So set up the brackets. It's x and x at the front because it's x squared. And we found our numbers. So we just need to pop those in there. So plus 4, plus 3. Right, final example. Is it a common factor? Sorry, is there a common factor in this expression? No. Is it a difference of two squares? No. Is it a trinomial? Yes. Does it have a 1 in front of the x squared? No. Therefore we can't use this pattern method used up here. So we're going to use our table method. So first thing we look for, 2 terms that multiply together to give us 3x squared. So that's 3x and x. And then we want 2 numbers that multiply together to give us 6. So let's go for 6 and 1. Multiply across. 3x multiplied by 1 is 3x. X multiplied by 6. 6x, add together, gives us 9x. So that's not going to work because we're looking for 19x. Let's try this one. Sorry, I've run out of space. 3x multiplied by 6, that's 18x. And x multiplied by 1 is x. Add together, 19x. Ideal. Set up the brackets. Combine these 2 terms in the first bracket. So that's your 3x plus 1. Second bracket, combine those 2 terms, x plus 6. Right, now to our system. So the first thing we look for is a common factor. Next thing we look for, difference of 2 squares. Next thing we look for is our 1x squared trinomial, and we're going to use the number pattern there. So P for pattern. And the final thing we'll look for is if it's not a 1x squared trinomial, so this one down here, then we're going to use our table method. So the way I'd remember that is using these first letters. So C, D, P, and T. And the way I'd remember that is CDs play tunes. I hope that helps. Goodbye, and thanks for watching.